Hey everybody. Today we're going to take a look at some functions that we've been studying so far this semester. Most of them we've covered already. A couple of them will be coming up towards the end of the semester. But this is just to kind of look at their general shapes and talk about transformations, domain, and range all in one spot. So you can take a look at commonalities and differences amongst the different kind of functions that we either have been or will be studying this semester. So if you don't get all 6 of them right now, no worries. I'm going to be zooming in and we'll be taking a look at each one of them in a little bit more detail. So first I want to look at a quadratic function. So this is the one we did way back when. I've already drawn in all of the parent functions for all of the graphs. We're going to go in and talk about the domain and range. And then I'll put a little transformation in there to make sure we can remember how to make it move left, right, up, or down, or get wider or stretch and all that good stuff. So here's our parent quadratic function. F of x equals x squared. That's the same as y equals x squared. Our domain and range is all real numbers. Well, our domain is all real numbers. So you can write that negative infinity to infinity. And our range for our parent function is from 0 to infinity. So this is just for the parent function. Of course, we know if I change it, make it move up, down, left, and right, it's going to switch. But this is just for our parent function. So say I want to make this do something. Say I want to make it move right 3 spaces. So I'm going to put in 1, 2, 3. I want to make it move right 3 spaces. And I'm going to put this in a different color here. So that green that I just drew in there, I want to make it go right 3 spaces. My equation for this would be f of x equals. Now this is going to be the opposite of what you think. So it's not going to be plus, it's going to be minus. So the equation for that green parabola in there, I made it move right 3 spaces. It's going to be x minus 3 squared. And this is a little tiny 2. This is my exponent. If I wanted to make it move up 7 spaces, then I would do x squared plus 7. If I wanted to make it move or get wider or have a vertical stretch, then I would do y equals 3x squared. So we're just kind of taking a look at all kind of different functions all in one spot so we can look at commonalities that they all have. Let's take a look at another one that we've been working on. So absolute value function. So this is my parent function. It starts at the origin. It makes a v. F of x equals the absolute value of x. Our domain and range actually is the same as the other function, the same as our quadratic function. So my domain is all real numbers, so negative infinity to infinity. And my range also goes from 0 to infinity. Okay. If I were to make this go right 3 spaces, it would be an x minus 3 on the inside, just like it was with a quadratic function because our transformations are the same. Let's make it do something else. Say I want to go down 4. 1, 2, 3, 4. Say I want to make it go down 4. So I'm going to do that in the green here. So my equation for that would be f of x equals the absolute value of x minus 4. So I kind of put that in there. So this would be the f of x equals the absolute value of x minus 4. So my parent function is the one in the blue, and I slid it down 4 spaces. If you're doing a plus or minus, you add that on the outside. So this is the absolute value of x minus 4. So this is the absolute value function. Next up, I got a rational function. So moving on, we got a rational function that we'll take a look at. So this is my parent rational function. As you can see, I got a branch in the first quadrant and I have a branch in the third quadrant. So the quadrants are 1, 2, 3, 4. There are asymptotes here. So asymptotes are lines that my graph approaches but never touches. So this rational function here is going to get closer and closer, but there's an asymptote there. And the same thing here on the x and the y axis. So it's going to be something that it gets closer and closer to, but it never touches. So my domain and range for my parent function is all real numbers except the number 0. So for both of these, I'm going to put a little... So I'm going to say both of these, my domain and range is all real numbers except the number 0. And I'll be out your way in just a minute. There we go. So my domain and range includes any number in the world, decimals, fractions, whatever, all real numbers except the number 0. X cannot be 0 and Y cannot be 0 because I have an asymptote here. So meaning it's going to get closer and closer to the y-axis, closer and closer to the x-axis, but it's not going to touch it. So if I want to slide it or make it do something, let's see, we did one to the right, we did one down. Let's make it go to the left 2 spaces. So 1, 2. So this time my asymptote was at 0. This time I'm going to have an asymptote at the number 2. So it's going to go something like that. Of course, not the best picture in the world, but I'm sliding the whole thing over 2 spaces. So that would be my drawing that I have here in the green. So of course, not the best drawing, but I am handwriting. You can type it in Desmos to get a much better picture. So the equation for this, since I'm making it move left 2 spaces, will be the following. So I would have something like that. So f of x equals 1 over x plus 2. If I want to move this left or right, we add something to the denominator. All right, 3 more functions we'll take a look at. So we did quadratic, absolute value, rational. Now let's move on and take a look at a radical function. So here's my radical function down here at the bottom. So f of x equals the square root of x. This can be a cube root, it could be a 4th root, but right now we're just looking at the square root. Our domain and range is only in the first quadrant for my parent function. It's not going to be in any other quadrant but the first quadrant. So my domain is 0 to infinity, and so is the range. So my domain and range are both 0 to infinity for my parent function. It'll never be anything outside of that until I make it move left, right, up, down, or stretch. Let's make it move up 5 spaces. So if I want to make it move up 5 spaces, 1, 2, 3, 4, 5. Now my branch is going to look something like that, what I've drawn in the green. So we started down here at 0 and we moved up 5 spaces. So now my new equation that I'm looking at is going to be f of x equals the square root of x plus 5. And make sure that plus 5 is on the outside. So I made the whole thing move up 5 spaces. So make sure that your 5 is on the outside. So that's a radical function. Now, exponential functions will be coming up. So let's go ahead and see what their general shape is. So the one in the blue is exponential growth. You read from left to right. So from left to right, this graph is going up. It's going up. So that is exponential growth. The one in the oranges looking color is exponential decay. And this one is going down. Again, you read from left to right. The one in the orange is going down. The one in the blue is going up. It's growth if you have a number bigger than 1. And this will be coming up in a day or so. So if you have growth, you have a number bigger than 1. And if it's exponential decay, then you have some sort of fraction, a number between 0 and 1. So it's going to be going down. So my domain for this particular function, for my exponential growth, my domain is going to be all real numbers for exponential growth. So my exponential growth function is going to be all real numbers. And technically for the decay, that one is also going to be all real numbers. So I can go ahead and put in negative infinity to infinity. So my domain for exponential growth or decay, the parent function, the most basic one, is all real numbers. Now the range, just like the case is with a rational function that had an asymptote, an exponential function has an asymptote also. So this graph is going to get closer and closer to the x-axis, but it's not going to touch. And my exponential decay is going to get closer and closer to the x-axis, but it's not going to touch. So my range is from 0 to infinity. And the 0 is not included. So notice we have parentheses as opposed to a bracket. So this one here, the bracket one that I'm pointing at with my orange colored pencil, that one is included. So 0 is part of my answer. This has a parenthesis, so 0 is not included because it's going to get closer and closer to 0, but it's never actually going to be 0. And the same transformation rules would apply for this one as well. And last but not least, towards the end of the semester, we're going to take a look at some trigonometry. We're going to be taking a look at sine and cosine. So this is a sine function. So it goes up and down and up and down and up and down forever and always. So we say that it oscillates. So again, that'll be coming up a little later in the semester. But this is the general shape for a sine function. So we're getting into a little bit of trigonometry coming up in the coming weeks. So it'll go up and down, and the domain and range, let's go ahead and fill that in. So my domain is going to follow through with every number in the world. So remember, domain, you're looking left and right. Even though I have pi's and things like that, those are still numbers. I can do -2 times 3.14. So my domain is going to cover all numbers. So my domain, if I can squeeze it in here, it's going to be -infinity to infinity. So this says -infinity to infinity. Our range, however, I can look right here on where my bottom and top is. My lowest number is -1, so this graph never gets below -1, and my highest number is +1. So my range is from -1 to +1. All right, so I'm going to zoom out in just a minute here so we can take a look at all 6 of these graphs all together. A few of the take-home points that I want to say for these graphs. First thing is that all the transformations work the same, whether it's quadratic, absolute value, rational, radical, exponential, sine, cubic, quartic, whatever the case may be. All of the transformations are the same. If you have a number on the outside of your function, it's going to move it up or down. If you have a number inside of your function, it's going to move it left or right. If you have a number greater than 1, it's going to be a vertical stretch. If it's less than 1, it's going to be a vertical shrink. So all of that is the same regardless of which function that we're looking at. I also want to make a note that 2 of these functions have asymptotes. A rational and an exponential function both have asymptotes. So I'm going to write that in this box. So this one has asymptotes. And our exponential function also has an asymptote. So that would be a commonality that both of these functions has in common. Other commonalities, if you look at a quadratic and an absolute value, notice their domain and range is the same. Domain is -infinity to infinity, and the range is 0 to infinity. So quadratic makes a U shape, absolute value makes a V shape. Notice some other things that we have going on here. A lot of them, their domain is from -infinity to infinity. Quadratic has it, absolute value has it, exponential function has it. So a lot of them have the same domain. It's just the range that switches up. So again, just some take-home points, just looking at all 6 of these functions in one place. So hopefully you can see and better understand their domain, range, transformations, and things like that. So you should be able to recognize these different shapes, whether I give you an actual function to work with or not.